Again, what you studied in Math 120 is important, and it's important because it relates to all the courses that follow it, including calc. All right? What are you going to do now? Take its derivative, and this is going to be dy d theta. So dy d theta. You can also call it y prime, with the understanding that y prime means dy d theta. Let's write it down. What do you get? 5 plus 5 cosine theta. That's not so bad. And then minus 5 sine theta. And I know, let me look at that. It's impossible to deal with that. Not really. It's on an interval between 0 and 2 pi. So what I'm going to do over here, I got to find out where this thing takes on a 0, because it's defined everywhere between 0 and 2 pi. So I'm going to write this down for you. 5 plus 5 cosine theta minus 5 sine theta. And the big question is, when is it equal to 0? Let me divide through by 5. You get 1 plus cosine theta minus sine theta is equal to 0. What I'm going to do now is I'm going to just reorder it a little tiny bit, and I hope it's not too confusing when I do that. I'm actually going to say sine theta minus cosine theta. You may wonder what I'm doing there. I'm subtracting cosine theta from both sides and adding sine theta to both sides, and that would equal 1. All right? So then someone's going to say, I wonder when that happens. And you're only between 0 and 2 pi, so I'm not going to spend a lot of time dealing with that. I'll look at it, and what am I looking at? And again, we're really concentrating on the derivative. Between 0 and 2 pi. Then the big question is, when would this equal 0? I'm sorry, I didn't mean to say 0. I meant to say 1. All right? Now again, there's a variety of ways of doing this, but I'm looking at it and thinking to myself is, when would that equal 1? Well, one thing for sure, I know it would occur at pi over 2. And why is that? Well, the sine of pi over 2 is 1. The cosine of pi over 2 is 0. So that definitely works. I got to kind of move along. So I would say, where's the next candidate for this? And I'm looking at it, and I'm thinking that would occur at pi. All right? And the sine of pi is 0. That's pretty encouraging. And the cosine of pi is minus 1. And minus 1 is plus 1. So I'm going to say at pi. All right? Let me keep going. And I'm going to look for another value. I'm going to say 3 pi over 2. Unfortunately, 3 pi over 2, the sine is going to be negative 1, and the cosine is going to be 0. So that doesn't work. That's out of the question. So I got my critical numbers. Let me erase this business over here. I don't need that anymore. And I need to analyze derivative. And I'm going to look at it. And I know it's tough. I'm going to start to erase other things too, by the way, because I don't need them anymore. I got my critical numbers. And what I'm going to do is I'm going to try to make it a little bit easier on me, and I'm going to factor out of 5, and I get 1 plus cosine theta minus sine theta. And I'm going to start, maybe taking values between 0 and pi over 2. And, a good value there is something I can handle. And I'm going to say, if I took a number a little bit after 0, the cosine would be roughly 1, and the sine would be roughly 0. So I'm going to say it's positive over here. It's pretty simple. All right? And then I'm going to go between pi over 2 and pi, and I'm going to say a little bit past 90 degrees now. All right? So if I go a little past 90 degrees, I'll write this over here for you, a little past 90 degrees. So, on the right side of 90. Let me make sure you know what I mean. I'm looking for sine, by the way. I know it's difficult. 1 plus, I'm going to get a small negative number here. I know that much, right? And then what do you get over here? Well, you're definitely going to get like a minus 1 over there, right? Close to it. So I'm kind of looking at that. Now I'm going to say it's going to be negative over here. Right? Now, certainly you might say, I'm not comfortable with what you just did. I actually want to take another number. Let me show you that. Right? You say, I'm not comfortable with what you're talking about over here. Let's say you took a number between pi over 2 and pi that you felt was easy to do, and I'm going to say a number that I think would easy to do would be 135 degrees. Let me write that down for you. 5, 1, let's see. Cosine, when you're in that region, it would be minus 1 over root 2, right? And the sine would be 1 over root 2. Well, let's go through that. And what do you get there? You get, it's more difficult, I realize that. Like a polynomial or something. You get root 2 minus 2. Well, I hope you realize that 2 is bigger than root 2. It's definitely a negative number, all right? So I'm going to get my eraser out. Eraser's been over here. Yeah, if you're not comfortable with numbers I'm using, use the numbers that you're comfortable with. Okay, between pi and 2 pi, I'm going to choose a really easy number, 270 degrees. Definitely between them, right? What do you get? You get 5, 1. Now, the cosine, we are 270, right? You think about that. That's going to be 0. Minus, oh, look at that. If you did 270, you're at minus 1, right? Let me see if that's true. Yeah, that's minus 1. Minus 1 is plus 1. Definitely get positive. All right? No, we're not using calculus to do that. Could you make a mistake? Could you get tired? Of course you could. All right, let me get my pen back. Increasing, decreasing, increasing. So what do I know? On this open interval, I know I have a max at, this is local by the way, at the point pi over 2. I'm going to call this f of theta. And then I'm going to say f of pi over 2. Now, if you want to compute that, you can. I don't really need to. And then it's going to be a min at pi, f of pi. And again, if you want to compute that, you can. So let's take a look at the notes and see what happens. The critical values we get, we got them over here. We got them written over here as well. Simple sign else, first derivative indicates that a maximum occurs at pi. I think I made another mistake in the notes. This is crazy. A lot of mistakes here. And I got to correct this. I just noticed it. So I'll correct these over here. These are wrong. And these are right. So a maximum at pi over 2 and a minimum at pi. All right? I'll correct the wording of it. Thank you. You're not going to see that, by the way.